Okay, so again, this is topic 13, solving using matrices. We're only going to look at topic 1 today, which is Gaussian elimination. So Gaussian elimination, also known as row reduction, is a method that consists of a sequence of operations performed on a matrix in order to solve. Okay. So the goal of Gaussian elimination is to put all of our system of equations into a matrix and then get that matrix into standard form. So standard form for a matrix looks like, there's two different ways. It either looks like 1, 0, 0, 1 with our numbers here, or it can look like 0, 1, 1, 0 with our numbers here. The reason why we need a 1 and 0 in each row is because this is solving for our variables. So remember, the first column is x, and the second column is y, and that last column is what it's equal to. So if we had at least a 1 in each of our rows, this is telling us that we either have x equals the number or y equals the number. So again, just like when we solved system of linear equations last time with the elimination and substitution method, our goal is the same here. Our goal is still to get a number for x and y. Okay? So let's look at number 1. So for number 1, our first step is to take this system of linear equation and turn it into a matrix. Okay. So doing that, what would be on our first row? 5, negative 2, and then equals 13. What about our last row?
2, 1, 7.
Good. So we turned our system of equations into a matrix, but notice this matrix does not match either of these standard forms with the 1s and the 0s. So our goal is to turn this matrix into a standard form. So what we would look for first, so I'm going to be labeling this row 1, row 2, is to see if we have any 1s already in our problem. So do we have a 1 already? Good. In row 2, we have a 1. So I'm going to circle that 1. Then we're going to look at the number either above or below it, and that number is going to have to be 0. So that means we have to turn this 2 into a 0. Okay? We do that by manipulating this matrix and writing our row reduction formulas. So in order to turn that negative 2 into a 0, we would have to multiply row 2 by 2, so 2 row 2, and add that to row 1, and that would give us our new row 1. Okay? This is not a fun topic. So we're going to go ahead and do what that is saying in our next step. So we're rewriting our matrix. So the only row that's changing is which one? Row 1 or row 2?
Row 1.
Row 1 is the only one that's changing because we said equals row 1. So that means row 2 stays the same. So I can rewrite row 2. 2, 1, 7. Only row 1 is changing. So in order to get that new row 1, we're going to do 2 times row 2. So 2 times 2 gives us 4. And we add that 4 to our row 1, which was 5. So 4 plus 5 is 9. Okay, that's our new number there. Now we're going to do the same for the next number. So we do 2 times row 2, so 2 times 1, which is 2. Add that to negative 2, and we get
0.
0, which is what we were looking for. Okay. Then we got to do it still to the last number over here. So we do 2 times row 2, so 2 times 7, which is 14, and we add that to 13, which gives us 27. That is our new matrices so far. Notice how we have a 1 and a 0, right? Okay, now we need to create our other 1. So what number am I going to be circling to change into our 1? 9. Well, not circle, underline, because that's what we're doing next. So again, this is row 1, row 2. How could we make that 9 a 1? So we can't just subtract a number from a row, because notice if we do that, we would have 0 minus 8, which would give us negative 8 there instead of 0. That 0 has to stay there. What's another way to get rid of that 9?
Can you multiply everything by 0? Oh no, because we need it to be a 1.
Yeah, we need to be a 1. How are we going to get 9 to be a 1? Divide by 9. So we are going to divide which row by 9? Row 1 or row 2? Row 1, because we want that 9 to be a 1. So writing our equation, we're doing row 1 divided by 9 is giving us our new row 1. So if we're rewriting our matrix, which row did not change? The second one, so I'm going to rewrite it, 2, 1, 7. The only row that's changing is our first row, and we're going to divide all those numbers by 9. So 9 divided by 9, 1, 0 divided by 9, 27 divided by 9, 3. So now we have our new matrix. So we have a 1, a 0, a 1, which means what do we need to make that 2? A 0. And then we're going to have it in standard form. Okay? So last step here, how are we making the 2 0? So if we divide everything by 2, that's going to make the 2 a 1. If we multiply by which row by negative 2? If we multiply row 2 by negative 2, we get a negative 4. But you're on the right track. Which row would we multiply by negative 2? Row 1. So negative 2, row 1. So that would give us negative 2 at the top. So that means we would have to add it to which row? Row 2 to get our new row 2. So when we do that, negative 2 times 1 is negative 2. Add the 2 that we're trying to change to 0, and we get 0. So doing that, which row stays the same? Row 1, so 1, 0, 3. So only row 2 is changing. So we're going to do negative 2 times row 1, which is 1. So that's negative 2. And then we're going to add it to row 2, which gives us 0. Negative 2 and 2 gives us 0. Then we're going to do the same for the next number. So negative 2 times row 1. So what's negative 2 times 0? 0. Add it to the row 2, we get 1. Okay. And then negative 2 times row 1, which is negative 3. So what's that?
Negative 6.
Negative 6. And then add it to row 2. 1. Okay. From here, we have our answer. Because remember, this is our x, this is our y. So in this case, we know that x is equal to what number?
I thought your listener says the same. Row 2, no?
Sorry?
Row 2 didn't say the same?
No, row 1 was staying the same. Row 1. So whatever we have equal to right here, that's the row that's changing. Okay. So what's our answer here for x? X is 3. How do we know x is 3 and not 1? Any guesses? This is the hardest thing we're going to do all semester. Good, because if we look at that first row, if we were to write that as an equation, we would have x plus 0y equals 3, which is the same as just saying x equals 3. Because that's where the 1 value is. It's in the x place. So where's the 1 value in this one? The y. So this is telling us y is equal to 1, which means we have the point 3, 1. And we would get the exact same thing if we did elimination, if we did substitution, if we would graph it, or use Gaussian method.
I think I will talk with Gaussian. Unnecessary.
We can see
Okay.
this on the YouTube post, right?
Yeah, I'm going to post this video too. Okay, so let's look at... We're not going to do all these examples because they're a lot. So I'm going to pick... We'll go ahead and do the next example. So I will tell you on the next test, you are going to have one problem in Gaussian method, one problem in Kramer's rule. We're going to talk about Kramer's rule on Wednesday.
So the questions about Gaussian eliminations, we
Yeah.
put the standard form and then figure out what x and y value is and put the point.
Yes. Yes.
All three.
So on an exam, I would have to see every single one of these steps. There's no way you could do any of that in your head. I can't. I mean, I have to write it all down. And even I get confused sometimes writing it down. So I need to see all these steps here to show that you know you're turning it into a matrix, getting it into standard form, and then writing your answer. You could always check your work by using substitution and elimination to make sure you got the answer right, but I would have to see the method for Gaussian. So let's look at number 2. Number 2, our first step is to do what? Put it into a matrix. So what would be our first row? Good. And our second row? 7, 4, 1. Okay, so we're looking for here to see if we have a 1 in our first 2 by 2. Do we have a 1 or a 0 here? No. So that means it does not give us a starting spot. We're going to have to create that starting spot. So what we're going to do is we're going to try to make this value here to be 0. And the reason I'm choosing this value is because I can manipulate this row right here and multiply this number by what? -2 or +2? +2, that would give me a -4, which I could add to a +4 and get 0. So right there, I just created my equation. So I said I'm going to do 2 times row 1, and then I'm going to add it to row 2, and that's going to give me my new row 2. Okay. So doing that, which row stays the same? Row 1. So I'm going to rewrite row 1. And then I'm going to go through my equation to find our new row 2. So we do 2 times row 1, so 2 times 3, which is, and then add that to 7. 6 and 7? 13? Oh, I was hearing like 19. Okay. Then we do for the next number. So 2 times row 1, which is that -2, gives us -4. Add that to 4. We get 0. Okay, next one. 2 times row 1 So 2 times 19, 38. And then 38 plus 1, 39. That is our new number here. Okay, we got our 0. Okay. Now that means once we have one of our numbers, so 0 or 1, we always try to find the opposite. So we need to find a 1, meaning a 1 could either be found here or here. Which one's the easiest, do you think, to deal with first? It's the 13. The reason why it's 13 is because we can do one thing to this row to make that 13 a 1. What could we do? Divide by 13. See, you guys are getting it, right? Row 2 divided by 13 gives us our new row 2. So that means which row did not change? Row 1. So I write all those numbers back. And the only thing that's changing is row 2. So I'm doing row 2 divided by 13. So what does that give me? 13 divided by 13? 1. Then I do row 2 divided by 13. That gives me 0. And then I do row 2 divided by 13. That gives me, not a decimal, 3. If you get, well, never mind, I won't say that. Because you can get decimals. Okay. So now we have our 0, our 1. So we just found the 1. That means we now find the opposite. We need to find 0 now. So which one are we turning into 0? The 3. So we're trying to make this 0. Once we do this a lot, you'll notice a lot of the steps are repeating. Because once we have a 1, we can always multiply wherever that 1 is by the opposite number, add it to get a 0. So knowing that, what would we multiply this row by? So when we add it to this, would give 0. Minus 3. So we're already forming our equation. Negative 3 times R2. So we said we're multiplying this one by negative 3. And we're going to add it to row 1. And that's going to give us our new row 1. Okay, so let's go ahead and do that. So it means which row is not changing? Row 2. Okay. So I have negative 3 times row 2. So what's negative 3 times 1? Add it to row 1, 0. Okay. Now I have negative 3 times row 2. So that gives me 0. Plus row 1, negative 2. Then I have negative 3 times row 2. So that minus 9. Add it to row 1, 10. Right? So we have now our 1, our 0, our zeros. That means we just need to do what to that negative 2? Turn it into a 1.
So would you divide by negative 2? No.
Correct. Divide which row by negative 2?
Row 1.
Row 1. So row 1 divided by negative 2 gives us our new row 1. So that means which row is staying the same? So 1, 0, 3. And now we're dividing every number in row 1 by negative 2. So what's 0 divided by negative 2? Negative 2 divided by negative 2. 10 divided by negative 2. Negative 5. Do we have this in standard form? Yes. So what is our answers looking at the matrix?
No, why?
Y is negative 5. Why is y negative 5 and not x? Good, because that's where that 1 is. Remember, this is x, this is y. So that means x is what? 3. So our point, and that is our answer.
So I'm about to confuse myself totally, but you turned that 4 into a 0. Could we have turned that 4 into a 1 and get the same answer? That 4y?
You could have turned the 4 into a 1, but how? That's the thing. It's kind of hard to think of a way to turn that 4 into a 1. Because if we could divide everything by 4, but now we're dealing with fractions. You have 7/4, 1/4. So
it was easier to turn into a 0.
Yeah. In this case, there's no one way to start. You gotta think, okay, which is easier, manipulate. Like, I can't tell you, always start with this number and do this, because that's not how matrices work. It's a lot of, think of it like a puzzle. It's just a big puzzle.
You said turning that 4 into a 1 would be hard. Man, the whole thing is hard. Period.